A timestamp represents the absolute value in time, independent of time zone. Timestamp is represented as the number of elapsed seconds since a fixed epochal time, which is also called the Unix epoch. In this offering, we will look into the various timestamp functions available in BigQuery. This is the Unix epoch clock, and the number ticking away shows the seconds elapsed since the Unix epoch time, which is considered 1970 January 1st. Let us see if the current timestamp returned by BigQuery and the Unix time are matching. To find the current timestamp, we have this function current timestamp. If we run this, it would return the current timestamp, and the result is displayed in a civil date format in UTC time zone. Now we need to find out what is the corresponding seconds for this timestamp. So for that, we have a function called unique seconds available in BigQuery. So for the unique seconds, we pass the current timestamp as the argument. And if you execute this query, it would return this number, which is matching with what is the current Unix epoch clock is showing. Now, I said that January 1st, 1970 is considered as the epoch date. So the Unix seconds corresponding to that time would be 0. Let us see if that is true. For that, we have to construct a timestamp pointing to 1970 January 1st and get the unique seconds corresponding to that. For constructing a timestamp, we have this function called timestamp, which accepts a string argument. So here I am going to pass 1970 0101, and I would pass the time as 000000. Now if I run this, it would create a timestamp pointing to 1970 January 1st in the UTC time zone. Now if I pass unique seconds here, this should print 0. So this shows that in 1970 January 1st is the epoch date. The timestamp function also has two more variants. The first variant which we saw was passing the string. In the second variant, it accepts a datetime object as an argument. So here I'm passing a datetime object, and I'm going to construct the datetime object passing a string. So I will pass 17th of August and some time, say 9 o'clock. Now if I run this, it created a timestamp object 9 o'clock UTC. All the timestamp functions also takes a second argument, which is a time zone. So I can pass a time zone also here. Say I pass Asia, Calcutta as a time zone. Now if I run this, it actually printed 3:30 UTC, which is corresponding to the current time in Calcutta. The third format of the timestamp function is where we can pass a date as an argument. So when you are passing a date, obviously you have to remove the time, and I can pass a date and create a timestamp. So when you do this, automatically the time will be set to the midnight. Now the timestamp is internally represented as the number of seconds since the Unix epoch time in the BigQuery. So obviously, given this epoch time in the seconds, we should be able to construct a timestamp object out of it. So let me quickly grab this current epoch time, and I come back to this timestamp, and I can pass this as the argument here. So there is a function called timestamp seconds, which accepts this seconds since the epoch. And when you run this, it would create a timestamp object in the UTC time zone. And if you see this, it is actually matching with the current UTC time, 1835, and this is 1829. Now, when you are printing a timestamp, it always is printing in the UTC time zone. But we have an option to change the time zone and print this date and time in different time zones. So for example, we have this function called string, which accepts a timestamp and converts it into a string and prints it. So for this string function, it accepts a second argument, which takes the time zone name. And if I run this, it would print the result as the time in Asia Calcutta, which is UTC plus 5:30. So I can also compare this. So I will do another string function and pass the same arguments. So I'll pass the same argument here, and I will call this as UTC, and I will call this as IST. So if I run this, you can see that 6:29 is the time in UTC, and the corresponding time in IST is 11:59 p.m. The format timestamp function is used to format a timestamp into various formats as given by this first argument of format string. So in this example, we have converted the given timestamp into Wednesday, August 17, 6:29, 2 p.m. The format timestamp also accepts an argument which is the time zone. So if you pass the time zone, it would print the time corresponding to the time zone given. So 6:29 UTC is converted into Asia Calcutta time, which became 11:59 p.m. Format is used for printing. Its equivalent function for creating a timestamp is parse timestamp. The parse timestamp creates a timestamp from a given string. So let us use the same format string. I will grab this time and I will paste it as the argument here. Now, if I run this, it would create a timestamp object for me in the UTC time zone. But you can see here that the date is coming as 1970. The reason why the date became 1970 is the string which we gave didn't have any date, any year mentioned in the date. So it took the year as 1970 by default. So to fix this, I can also pass an year to the date, and I will add the corresponding format string corresponding to the year, which is %y. Now if I run this, it would create a timestamp pointing to 2022. Now let us look into some timestamp arithmetic functions. The first one would be the timestamp add. Timestamp add takes two arguments. The first argument is the timestamp and the second argument is the interval. So the timestamp, let me pass the current timestamp itself as the first argument, and in the interval I will add say a 10 minutes. So this would add 10 minutes, which is like 53 became 03. In the same way, we have this function called sub, which would subtract 10 minutes from the given timestamp. So 53 became 43. Now, while working with date or datetime, we had an option to pass year, quarter, week, etc. in the interval part. But while working with timestamps, we cannot pass all those options. So suppose if I pass 10 weeks here, this would result in an error. So the only valid options which we can pass here for the interval are microseconds, milliseconds, seconds, minutes, hours, or day. You cannot pass the other arguments. The timestamp diff is another function which computes the diff between two given timestamps in a given interval. So let me pass the current timestamp as the first argument, and I can do timestamp add and say an interval of 10 minutes, and I can pass the third argument as again minute. So I want the diff to be computed as minutes. Now if I run this, you can see that it printed -10, which is basically the difference of 10 minutes between the first timestamp and the second timestamp. The timestamp trunc function is to truncate the timestamp to the given granularity in the second argument, which is the date part. Say I have a timestamp object. Time would be 1 p.m. and I truncate it to the day part. Now if I run this, you can see that the hours, minutes, and seconds got truncated and it retains the date part. The timestamp trunc also optionally accepts a third argument, which would be the time zone. So let us say I have a timestamp like this, which is a timestamp of 16th of August, 1:30 in Asia Calcutta time zone. Now I am truncating the hours. So if I run this, you can see that the minutes and the seconds are gone and the hours came to 8 UTC. The reason is like 1:30 p.m. Asia Calcutta time is corresponding to 8 a.m. in UTC. So when it got truncated, it became 1 p.m., which is equivalent to 8 a.m. in UTC. Now we can also pass the third argument for the timestamp trunc, which is the time zone itself for truncating in the corresponding time zone. So suppose if I pass Asia Calcutta again here and I run this, so you can see that it became 7:30 UTC. We can see the corresponding time in the correct time zone by using the string function, and we can pass Asia Calcutta again. So it is actually 1 p.m. So we truncated 1:30 to the hour. So it became 1 p.m. and we are printing the time zone back in IST itself.